I didn't realize it was so hard to make an instructional video. But anyway, this is the 15th attempt or whatever. I have a Lasko 5160 model ceramic heater, which I use in the garage. This is it. The model number is on the bottom, but the video probably is applicable to a lot of different Lasko devices. My problem was that the digital display here, right here, would be stable, and then out of nowhere, or it was wonky. Out of nowhere, it would go from 75, like it is here, stable, to 89 or something. I use it in the garage, and it never gets 89 here in the winter time. And it would be okay, and then not. It was just wonky. So I looked around on the internet to see if anybody had experience with a 5160 Lasko wonky ambient temperature display, and there was nothing. Looked around on the internet for a wiring diagram, perhaps, or parts for the Lasko 5160, and there was nothing. It didn't help me at all. So I decided, oh, what the hell. I unplugged it and decided to take it apart and see if I could figure out what may be the problem. So the back here has 8 screws in it. You see those holes. There's Phillip head screws. You remove those, okay, with the power off. Always power off. I went to lift the back off of it, and it lifted off easily enough, but it turned out there was a 2-wire cable attached to a very small device, located just about where this white is, that went all the way up to the circuit board. So, most likely some sort of temperature sensor for ambient. And it looked like this. Had a very small head on it, like you can see here. Okay. And these connections went to the circuit board. It was sort of hot glued on the cable somewhere about here, and this particular device was just stuck in the airstream back here. Anyway, what is this? So I did a little research on the internet, and it turns out this is a 2-wire thermistor. And what a thermistor is, it's a resistor, which electrical element that resists current flow. The higher the resistor, the less current that will go through it. So anyway, what they do in this particular model is they measure the voltage across this, and this particular thermistor, it turns out, is what's called a NTC, or a negative temperature coefficient or correlation, whatever you want. And that means that starting from ambient, as the temperature goes down, the resistance of this device goes up. And the other way around, if temperature goes up, the resistance of this device goes down. And they use that and convert an analog signal into a digital display. Okay, so I couldn't find any parts diagram. I think this is probably the problem. But I have no idea, like everything, these things is 1,000 variations of a theme. So I doing research again, it said, well, it could be a 10K ohm, it could be 100K ohm, a 20K, there's all kind of sizes. So on eBay, I decided I would go with a 10K because that seemed about right for this particular application. We're not talking about a wide temperature range or anything, and super high precision. So I got to eBay some 10K NTC thermistors. Now what I got in the mail was meant to be mounted to a circuit board. It had no leads on it. So I cut the old thermistor off, stripped some wire on the leads, used a set of clipper cables, put in my 10K thermistor and plugged everything in. It worked just fine. So I knew that 10K is what I needed with a negative temperature correlation, but I didn't want to go to the trouble of having to try to attach wires to very, very small leads on the circuit board type thermistor. So I went back to eBay and I picked up this. And this has got a relatively long wire on it, and it's already got the heat shrink tubing where the electrical connections were made at the top. So again, I had already cut the wires in the back that went to the circuit board. So in my case, I took these leads, twisted them real well with the old leads. I put some heat shrink tubing on first. I soldered them, and then I slid the heat shrink tubing in place, heated it, and made a nice fit connection. Now, if you're going to do this yourself, you get the 10K NTC thermistor with leads like this. You cut off the old thermistor. Now you can just twist the two wires like this. You can just twist them one to the other and maybe use electrical tape. Or you could twist them together and use very, very small wire caps. I don't think that would be advisable, but nonetheless. And then finally, you could twist them together and then make what's called liquid electrical tape, which I use a lot. And you could coat the wires real well so that they couldn't short out. You're not talking about a big voltage here anyway. Just as a side note, I decided once I'd cut the wire, what would the circuit board decide to do? And what it did with no thermistor in place, it read 39 degrees, which basically says I had an infinite resistance because I didn't have any closed circuit at all. There was nothing there. That's the way the circuit board is calibrated, so the highest resistance it can see off of this device would be to go to 39 degrees, or display 39 degrees. 10K. 10K is what you get at ambient. If you were to try to put an ohm meter on your old one, cut one of the leads so it's not in the circuit, of course, and use an ohm meter at ambient temperature, you should read around 10K ohms, 10,000 ohms. That's at ambient. And again, the resistance goes up, maybe to 20,000 ohms at 39 Fahrenheit, and maybe 5,000 ohms at 85 degrees Fahrenheit. But anyway, that's what I did, soldered the new one in place, and then where to place it. The idea of going on the back, I was going to try to avoid that so I could easily take the back off again, but looking around, the circuit board gives off quite a bit of heat. You don't want to mount it up near that. That's the reason it wasn't soldered directly onto the circuit board. There's a big fat resistor up there that's putting off like 90 degrees of temperature. So you don't want to be up near that, and obviously you don't want to be down near the ceramic heater, even though there's a fan on it and it's pretty enclosed, but you don't want that. So where they originally had it made sense, was attached to the back, and that's where I have located my new thermistor. The wires come down from the circuit board over to here, and I used a breadbasket twisty tie to wrap around the leads of the thermistor, and the thermistor itself, although you probably can't see it, it is in there. The actual head is to the left of that twisty tie. Okay. I twisty tied rather than cable tied because, I never trust in nothing, and 2 weeks from now it starts getting wonky again, then I can try another trimester. These things are made, the millions of them every day, and they're not tested, so you know you get what you get. It could last forever, or it could last a week. Anyway, that's how I did it. Hopefully, it'll you can do it yourself. Maybe get a friend who knows how to do such things, but keep this stuff out of the landfill. Always repair over replace if you can. This new Lasko is like $80 or something, so it's worth replacing. And again, I don't want this thing in the landfill. You can't recycle it. Anyway, I hope it helps. Bye bye.